Hello, welcome. Sorry I'm not here today. Had to go to a workshop. I do want to continue our notes. Let me give you a time schedule of what's going on this week. So today we have this lesson 5-5. Last time we had a review. So this time this is a new lesson, 5-5. And then next time, so on Thursday, we will have another review, and then your test is on Monday. So please be ready for it. It's going to cover all the things that we've been covering, the stuff that was on the review from last time, and the stuff that's going to be on the new review, and obviously today's lesson. All right, so here is our new lesson. Before we get going on what our new lesson is all about, let's talk about what we have learned so far. 5-1. We talked about growth and decay. We had 3 formulas. I've told you that you really need to have them memorized. Some are man-made conditions, and some are natural conditions. We figured out constant rates of growth, time values, what's the ending amount, what's the beginning amount, stuff like that. Then we moved on to 5-3, and so points 2 and 3 here are from that lesson. One was understanding the relationship between exponents and logarithms, knowing that you have a base and a power, and it equals a number, and then it can be rewritten as a logarithm of a base and the power, and they have their appropriate spots, and you should be able to go forwards and backwards between the two. Then the big one was solving exponential equations. And the way we solved the exponential equations was to rewrite the problem so they had the same base on the left and the right. And in case you have forgotten how to do it, we're going to do an example of that in just a minute right here. All right, and then the last lesson, 5-4, we understood the properties of logarithms and applied them to solve logarithmic equations. We watched the videos from Nancy at Math BFF, and where there was 2 types of logarithmic equations. So one where you have a log equal to a number, and you have to use property 1, which is to rewrite that as a power, just like over here. And the other is when you have a log equals a log. And Nancy called it the equality property. There's a little bit more to it than the equality property, but basically it says if there's an operator that's the same on the left and the right, you're allowed to cancel them out. And we've done it several times. All right, so now today's is a lot different. Well, it uses these that we've already done, but it kind of goes back to number 3 up here, solving exponentials with a common base. But what happens if we can't get a common base? Solving exponential. So what we're going to be doing instead is solving exponential equations with a logarithm. We'll have to use a logarithm. But let's kind of get a reminder of what we have been doing so you can see how it's connected to what we will be doing. So it says we had a problem like this earlier, and we would have done this with a common base. Find a common base. And then we canceled out the bases. All right, so that was the first thing we did, was try to rewrite it so it had a common base, and then cancel out the base once you've done that, and then finish solving the algebra problem. So I would have taken the right-hand side, and I would have tried to figure out a way of rewriting 343 so that it's a power of 7. So that's when you get out your calculator, you just start number crunching until you find something that you think will work. In this case, 3. Now, we just canceled the 7s out from here, the bases. We just canceled them out. The powers dropped down. And I just finished solving the equation that's left over. Sometimes it's linear, sometimes it's quadratic or polynomial, whatever the case is. And in this case, we get x equals 2. And you probably should check it to make sure, but I'm pretty sure we did it right. So that's what we have done before. We are allowed to rewrite both sides as a base 7 number. We canceled out the 7s. But what was really going on, it says what allows us to cancel out the bases is the tool that we will use when we cannot cancel out the bases. All right, so what I'm saying is the thing that allows us to get rid of those 7s is something that we're going to use when we can't get rid of those 7s. We're still going to be able to use it in a different way. So I'm going to go ahead and model what I want to talk about using the problem that we just did. So here's what we did so far. 7, 2x minus 1 equals 343. And let's just say I forgot that I needed to change this to a base 7 number. Or let's say I even did remember to change that as a base 7 number. What does it look like? So I'm going to say, let's go ahead and say we remembered. Okay. So what is really allowing us to do that is the inverse of base 7. It says right here, inverse of base 7. So I'm going to give myself a little bit more room here. If I do the inverse of base 7 is log base 7, just like when we had problems that had e. To get rid of this e, we did the natural log, because anytime I do a base and its inverse next to each other, they cancel out. And that's what I want to do here. I now have a base next to its inverse, so it's going to cancel out. Now what I do to the left-hand side, I must do to the right-hand side. And again, I have a base next to its inverse, so those cancel out. So that's really the tool that is allowing us to cancel these out. I know they call it the equality property, but basically what the equality property says is if there is an operator that's both on the left and the right, then there's an inverse operator that gets rid of them. There's a lot going on. We just try to take some shortcuts. Okay, so now we're going to use it where I cannot rewrite it as a same base. There is no power of 35 that I can write, or no power of 5 that I can write, because 5 squared is 25, 5 cubed is 125. There's no integer that gives me 35. How do I solve this one? So we're going to pretend that we could. And so we're going to use log base 5. I want to get rid of this 5 because I'm trying to figure out what x is. X is in the power. I have to get it out of the power. So I'm going to do log base 5 of 5 raised to the 5 minus 2x. Now the reason we're doing that is because I want to get rid of that base so that the power drops. The problem is I have to do the exact same math on both sides of the equal sign. So I also have to do log base 5 of 35. But nothing cancels out this time. That's okay, because we have this does cancel out and this drops down. And we have a way of converting this with our calculator. It was earlier in one of the earlier lessons, but this can be converted by doing log on my calculator of the bigger number, 35, over log of the base. Remember, the base goes in the basement. The only thing you have to watch out for is that needs to be closed parentheses before you hit divide sign. So right now on your calculator, go ahead and do log base 35, close parentheses, divide log 5, and see what you get right there. So when I did it, I got 2.209, and it goes on forever, 0.61955. And normal practice is just to do 3 decimal places, so we'll do 3. If you want to get a little bit more accurate, I guess you could do 4 decimal places. In this case, I'd call that a 1. All right, so now it's just a number. Yeah, it's not a pretty number, but it's just a number. And you're going to solve this like you normally would. And we get 1.3955. And you can check it back in here, plug it in with your calculator, and see. You're not going to get exactly 35, but you should get something really close.